So welcome. So in this short session, we are going to discuss about the factorial function, the gamma function, and the beta function. So these functions are very key in solving problems in engineering and in statistics. So start by discussing about the factorial function. So factorial function or factorial x is written by this notation and is defined as x times x minus 1, x minus 2 times x minus 3 up to times 4 times 3 times 2 and then times 1. And in this definition, we take x to be a natural number. So it just simply means that if you have any natural number, to define its factorial, you take that natural number, you multiply by that natural number minus 1, then next you subtract 1 up to the point you reach 1. Now, by convention, we take 0 factorial to have a value 1. And so once you define x factorial in this form, as given in this equation, if you start at the point x minus 1, then times x minus 2 times x minus 3 up to times 1, then that will be defining x minus 1 factorial. So therefore, x factorial can as well be written as x times x minus 1 factorial. Similarly, if you start defining a product from x minus 2, x minus 3 times x minus 4 up to times 1, then from x minus 2 up to product 1, you are defining x minus 2 factorial. So therefore, x factorial can as well be written as x times x minus 1 times x minus 2 factorial. Similarly, x factorial is the same as x times x minus 1 times x minus 2 times x minus 3 factorial. The reason as to why it is always it's good to know these relationships is because you may be asked to simplify some factorial expressions, and expressing higher factorials in terms of lower factorials can help you to know how to simplify such expressions. For example, if you are asked to simplify the expression, if the question is simplify, say 100 factorial over 98 factorial, then you do not have to multiply 100 by 99 up to 1, then divided by 98 times 97 up to 1. You simply write this one as 100 times 99 times 98 factorial, and then divided by 98 factorial, so that 98 factorial cancels out, and then the answer becomes 99 times 100, which will be given by this. Or if you're asked to simplify n factorial over n minus 2 factorial, you simply write this one as n times n minus 1 times n minus 2 factorial, and then divided by n minus 2 factorial. So this and this cancels out, and you have n into n minus 1, which is n squared minus n. So that's why knowing how to write higher factorials in terms of lower factorials can be very useful to help you simplify some problems. Now, with that, we can give a few examples. If you're asked to define 2 factorial, simply means 2 times 1, which is 2. 3 factorial means 3 by 2 by 1, which is 6. 4 factorial is 4 times 3 times 2 times 1, which is 24. 5 factorial is 5 times 1 times 4 times 3 times 2 times 1, which gives 120. And you can define other factorials for other natural numbers in a similar way. Then next, there's what we call double factorial. Now, double factorial simply means that you use the sign for factorial twice. So we define double factorial of x as there are two formulas, x times x minus 1 times 5 times 2 times 5 times 3 times 1, when x is an odd natural number, and when x is an even natural number, then we use the formula x times x minus 2 times 6 up to times 6 times 4 times 2. So for example, 4 double factorial is the same as 4 times 2. So because 4 is an even number, and 5 double factorial is the same as 5 times 3 times 1, because 5 is an odd number, we use the first formula to get 15. And you see from this result on definition of the double factorial, we see that x factorial is the same as x double factorial times x minus 1 double factorial. So for example, if we want to define, so for instance, we are saying x factorial is the same as x double factorial, x minus 1 double factorial. Now, when I say like, for example, 5 factorial is the same as 5 and then 5 minus 1 double factorial. You see 5 double factorial, because 5 is an odd number, will be 5 times 3 times 1. And this is 4, because 4 is an even number, we use the second formula, so it will be 4 times 2. And you see when you rearrange this one, it's the same as 5 times 4 times 3 times 2 times 1, which is the same as definition of 5 factorial. So therefore, x factorial is the same as x double factorial times x minus 1 double factorial. So after defining the double factorial, let's define what we call the falling factorial or the descending factorial or lower factorial. So it's denoted by x sub n, which is defined as x times x minus 1 times x minus 2 up to times x minus n plus 1. So the falling factorial counts the words of longitude n in order without repetition. And as an example, when n is 0, so x falling factorial of 0 is 1. When n is 1, we'll have x. When n is 2, we'll have x times x minus 1, which simplifies to x squared minus 1. And when n is 3, we'll have x into x minus 1, x minus 2, which simplifies to x power 3 minus 3x squared plus 2x. And when n is 4, we'll have x into x minus 1 into x minus 2 into x minus 3, which gives us x power 4 minus 6x power 3 plus 11x squared minus 6x. So when you pick x, for instance, to be 5, and we pick n to be 3, then you are going to use this formula. The answer will be 5 times 4 times 3, or simply using this equation here. So when you put where there's x, you put 5. So we'll have 5 cubed. Using what we have in number 4, we'll have 5 cubed. And then minus 3 times 5 squared. And then plus 2 into 5. And you get the answer as 60. So that's how we define falling factorial. And also we have what we call the rising factorial, or gamma factorial, which is defined as x into x plus 1, x plus 2, up to x plus n minus 1. And as an example, so when n is 0, we'll have 1. When n is 1, we have x. When n is 2, we'll have x into x plus 1, which simplifies to x squared plus x. When n is 3, we'll have x into x plus 1, x plus 2, we get x cubed plus 3x squared plus 2x. And when n is 4, we'll get x power 4 plus 6x cubed plus 11x squared plus 6x. So when you take x to be 2, and then n to be 3, we, using formula 4, we get the answer to be 24. And then we now define what we call gamma function. So gamma function of x is defined by this improper integral from 0 to infinity, t raised power x minus 1, e raised power minus t dt. So where x is not negative natural numbers, negative integers and 0. So with the definitions of the falling factorial and the rising factorial, we can as well express the gamma function in terms of the falling and rising factorial using these two formulas. And then common gamma function rules and facts. These rules or facts can help you to simplify some problems that involves gamma function. So we have gamma of x plus 1 is the same as x gamma of x. And so from this same formula, you can make gamma of x the subject, and that will give you gamma of x plus 1 divided by x. And also gamma of n plus 1 can be expressed in terms of a factorial function, which is the same as n factorial, or gamma of n is the same as n minus 1 factorial. These formulas can easily be proven, and the results are very useful in simplification of gamma functions. Then gamma of a half is given by root pi, gamma of 1 is 1, and also gamma of 2 is 1. But gamma of 0 is plus or minus infinity, gamma of -1 is plus or minus infinity, gamma of -2 is plus or minus infinity, etc. And if you define gamma of z and you multiply by gamma of 1 minus z, then it can be shown that the result simplifies to pi over sine of pi z, where z is a complex number. Then beta functions, by definition, beta functions with two parameters m and n is defined as the integral from 0 to 1 x raised power m minus 1 into 1 minus x raised power n minus 1 dx. So we also have other alternative definitions of beta function, which can be given in terms of the trigonometric function as the integral from 0 to pi over 2 sine raised power 2m minus 1 theta cos raised power 2n minus 1 theta d theta. And also we have beta function defined in terms of the integral from 0 to infinity x raised power m minus 1 over 1 plus x raised power m plus n. Now, it is always advisable to know all these three different definitions of gamma function, of the beta function, because you may be given a problem that requires a simplification using the first definition, where the limits are from 0 to 1. Sometimes you'll be given a problem which has limits, which dictates that you need to express your limits from 0 to pi over 2, which calls for the definition given in 1. And sometimes you may be given a problem to solve which requires your limits be from 0 to infinity. So you have to know that this is the structure of the definition of the beta function with parameters m and n. So ensure that once you know the definition of this beta function with parameter m and n, you also remember these other alternative definitions that can always be very useful depending on the situation or the kind of problem you're solving. Now, also we have some facts about beta function, that beta function of parameters m and n is the same as beta function of parameters n and m. That beta of mn is the same as beta n m. And it can also be shown that beta function of parameters m and n can be expressed as factorial, as gamma functions, which is gamma of m times gamma of n divided by gamma of m plus n. And also, because we know we can express gamma function in terms of factorial function, then beta function can also be expressed as factorial function as given in this formula 3. So those were the few or a summary on factorial and gamma and beta functions that will be very useful in helping us to solve problems in mathematics, engineering, and statistics. And when you start solving problems, we'll prove some of the facts or the rules that we have stated in this session. So thank you.